Ooh, Algebra 2. I am recording a quick seminar on the Khan Academy exercises that were assigned this week on inequalities. I've got requests from a number of students for some help on these problems. I'm going to go through each problem, one example, maybe two examples for each problem, and hopefully I'll be able to guide you to the different problems. So we're starting with solutions of inequalities algebraic. Copying this. Is it a solution? Yes or no? And pasting that. And now are we going to decide if that's a solution? Well, we can decide by taking the points and plugging them in. So we're taking the -4, plugging it in for x, this -4, plugging it in for y, and seeing if we have a true statement. -4, is that greater than -6 times -4 minus 1? We're checking it. -4, is that greater than 24? -6 times -4 is 24 minus 1. Is -4 greater than 23? It is not greater than 23. And that means that the answer should be no. Let's go back and see. Next exercise, solutions of inequalities graphical. It's just like the last one, but in this case we're using a graph to answer. Is -2, -4 a solution of the graphed inequality? So what we're going to do is check to see where this point is on the graph. -2, -1, -2, -4, -1, 2, 3, 4. That point right there, -2, -4. And that point is in the shaded region, which means it is, yes, a solution. While we're here looking at this graph, let's consider this point right here, 2, -2. Would 2, -2, if instead of here it said 2, -2, is 2, -2 a solution? No, it is not. Since this line is dashed, it means that we're not including the points on the line, right? If we think about right here what this shaded region is composed of, it's a bunch of number lines where the end points of the number line are not included, open circles. That 2, -2 is not included. No, that would not be a solution. But this is, yes, a solution. So we go back and we say, yes, -2, -4 is a solution. Doesn't ask us about the other one. They made it a little easier on us. Solutions of systems of inequalities. Okay, so now they're looking to see, is this point here, 3, 5, a solution to the system, not just an individual inequality, but the whole system? To check, we just take the point, plug it in to the first inequality, take our x value and plug it in for x, our y value, plug it in for y. See if it satisfies that inequality. 7 times 3 minus 9 times 5. Is that less than 5? We're checking. 21 minus 45. Is that less than 5? 21 is bigger than 45, so we're going to get a negative number, -24 specifically. But once you know it's a negative number and you know it's going to be less than a positive number, You could say yes. Do we then answer the question and say yes? No, not yet. We need to check the other inequality. So we're going to take 3 and plug it in for the x, 5 and plug it in for the y, and see what we get. Negative 2 times 3 plus 4 times 5, and check to see if that's greater than 5. Negative 6 plus 20, is that greater than 5? 14 is definitely greater than 5. So the answer to the question, since this point satisfies both of the inequalities, it is a solution to the system of inequalities. And we go back and we say yes. Next exercise. Graphs of inequalities. Which graph represents? So here we come on graphing. We're just going to make a quick graph of this. For x plus 7y. Left that a little too small. Sorry for my eyes. Much better. So to do this, we're going to move the 4x to the other side. 7y less than or equal to 4x minus 21. These two inequalities, according to Khan Academy language, are equivalent inequalities. What that means is that the solution to the two inequalities is the same. All the solutions to the first inequality are also solutions to the second. Why does that work? If we subtract 4x from both sides. Whoa, I missed a negative sign here. That's serious. Glad I caught it. Right, we moved the 4x to the other side. We subtracted 4x from both sides. Well, what we're doing, if we imagine the relationship between the left-hand side, so if we drew ourselves a number line, and we have the left-hand side is less than or equal to the right-hand side. Well, whatever the left-hand side and the right-hand side are, right, we have some solid thing here and something like this. Well, we're moving the left-hand side, when we subtract 4x, we're moving that to the left, and the right-hand side the same amount to the left. So the relationship between these quantities isn't going to change. It's going to look the same, just move to the left on the number line. Now x could be negative, but that would just mean that we're moving to the right. We're not changing the kind of way that these quantities relate to each other. They're still in the same order. Now we divide by 7. Same thing. Still preserves that relationship. Dividing by 7 squishes the number line. Everything moves closer together, but it stays in the same relation to each other. Something on the right stays on the right. Something on the left stays on the left. Lost my x. And now we want to make a graph of this. We have a slope of negative 4/7, a y-intercept of negative 3, and we can graph it. Negative 3, let's put it about here, negative 1, 2, 3. Should I have done a solid dot at negative 3? Yes, because we are including the case where they're equal, where the points are on the line. And we have a slope of negative 4/7, which means down 4 over 7. Get another point, and let me try to actually connect those. And now do we shade above the line or below? Since this is less than or equal to, we're thinking about number lines like this going down, number lines going down, and we're shading below the line. So that region, the pink region including the line. And we can go look. I apologize for making that entire graph over to the side where you couldn't see it because of my big blockhead here in the video. But you can see we started at -3, went down 4, right 7, connected the points, shaded below the line. Let's look at Khan Academy. Here we see we've got something that looks approximately right. I haven't checked the values on the graph. Let's see if any others look better. This one is a dashed line, can't be that. This one is a dashed line, can't be that. This one is up above the line. It wasn't that, it was less than or equal to. So even without checking, we can see that B is correct. The next exercise is 2 variable inequalities from their graph. Find the inequality represented by the graph. We have to actually write the inequality. This one's too big. Find the inequality represented by the graph. We can start by writing the equation of the line. So this line. To write the equation of the line, we can count our slope to get our slope. And note that we're being given our y-intercept. That's B. It's a point on the line that's on the y-axis. So we know our y-intercept. We went down 2, down from -3 to -5. That's down 2, down 2. And then we went right just 1. So our slope is -2 over 1, which is just -2. And we can write our equation for the line, write the equation for the line first. Y equals -2x minus 5. Remember, B was -5. Now, we have to figure out, do we want above the line or below the line? Well, if we think about a particular x value, like x is -1, well, we can see that here we have shading in the positive direction. We want all the values greater than this particular y value, than this value here, -3. When x is -1, right, if x is -1, we want everything greater than, so we've got to put a greater than or equals there. Whoa, that was a messy greater than or equals. And there's our answer, and we can try it in Khan Academy. Y greater than or equal to. Y greater than or equal to -2x minus 5. Hit check. And we got it. On to the next. Here we're being asked. Oh, it looks like we got this one already. Let's do a new one. Ooh, nope, we don't have it. So we get to do it. The next one, systems of inequalities from graphs. So let's grab the problem. We're going to graph this system. You can, if you're quick, note, look at this, less than, that means dashed line, less than, that means dashed line, not dashed, not dashed, not dashed, eliminated, right? A, B, and D all right away, and we know the answer has to be C. So we can do it that way, but let's, just for a little bit of practice, do the problem. Whoa, that's way too enlarged. And here we go. So they're already solved for y, so we can just pull out m. M is -1, b is -2, m is 1, b is 1, and we just graph these. B is -2. Strict inequality, circle to indicate that I'm not including the point. Slope is -1, down 1, right 1. Another open circle, down 1, right 1. Another open circle. And at this point, draw some dashed lines through here. And do I shade above or below? Less than means I shade below. So I shade of this. And now we do the second inequality, y less than x plus 1. So here we have +1, strict less than, so an open circle, slope of 1, up 1, over 1, another open circle, up 1, over 1, another open circle, and we draw a dashed line through those, and we shade, since it's less than, below. And you can see that below is this triangular region that doesn't end really an angle, region contained in an angle. This region here on to infinity. So this kind of dark blue area, but continuing on in this direction and this direction, or more appropriately, if you think about the number lines underneath, that down and down and down and down and down. Okay, so now we can go back to Khan Academy and look at the graphs. We already decided that the answer had to be C, but we can see that those match up pretty well. And we get our sound. Okay, the next exercise. Constraint solutions of two variable inequalities. This is one of my favorite of the assignments from this week. Because it utilizes the skills that we've been working so hard to develop around conceptual understanding for for number lines and how number lines work. Remember, when we think of this number line, what we're really when we think of this graph of an inequality on the coordinate plane, what we're thinking of underneath is that it's composed of a bunch of number lines. Array here, starting, not including the endpoint. One like that. Another one right here. Another one right here. Another one right here. Another one right. All of these infinitely many number lines all along that line pointing up. And what they're asking us to do is to consider what happens when we know x is 2. So if we go over to 2, 1, 2, here we're looking at 2. What is the constraint when x is 2? And so if we focus on that line, right? What do we want on that line? Well, we want everything that starts at, I kind of messed it up with that. It's hard to see the coordinates. Let's go back. There we go. It looks like the coordinate there is -5. So again, we're focusing on this number line, and we want all of the values not including this point and above. And what we can do is just envision taking that and rotating it. And there we have our number line. We're going from -5. We're going from -5 up to infinity. So our y values are greater than -5. And so we go back to Khan Academy and we look for y greater than -5. And we get it. The next exercise, our final one, another constraint solutions. Another opportunity to use our conceptual understanding. Here we're being asked to look at a graph of a system, not just a single inequality, and to consider what happens with a particular x coordinate. Some of these might give you the y coordinates, the same kind of thing. Which y value makes the ordered pair for y a solution? So here we're taking this, and we know x is 4. We know x is 4. So we're going over to x is 4, and we're looking at the line segment through x is 4. Oh my gosh. Come on. It's so hard to draw a dashed line with this thing. Oh, you know the way to do it. There we go. Make it thicker. Makes it a lot easier to do. There we go. And now we're looking at this point right here, right? And should I make it a solid point? It's on a dashed line. No. Open circle. Whoa. Need to change back to a small. Open circle. And this point up here should be, and this corresponds to 3, looking over here. And this corresponds right here to -1 by looking over here. So we have -1 where it starts, and it goes up to 3. And again, you can turn it sideways if it makes it easier to see. See that number line right there going from -1, going from -1 up to 3. So we want our y values sandwiched between -1 and 3. Dashed line at -1, so strict less than or equal to at 3 because we want to include 3. And we have our answer. Going back to Khan Academy, -1 less than y, less than or equal to 3. There's a less than or equal to. It should be less than. Scroll down, and here we see C has all of the characteristics correct. Okay, going on. Any of the regular Algebra 2 students, you're done. The rest of these are just for honors. You might see at least these first few. You'll see these next week, the word problem ones. But we'll go over some in class as well. Okay, 2 variable inequalities word problems. Lots of words here. Remember the cubes strategy, where we start by making sure to read the problem carefully. So what's going on with this problem? And remember the strategy I talked about. Even though we're using cubes and we're going to try to read it carefully, we're going to read it quickly first. We're just going to get a feeling for the scenario. What's going on in this situation here? Ifede, I'm not sure how to pronounce that. Ifede can use a limited number of spells to defeat trolls and goblins. Take the same number of spells to defeat each troll, 3 spells, goblins. Take T represents number of trolls, G the number of goblins Ifede can defeat without running out of spells. Some inequality. According to the inequality, how many spells does it take to defeat each troll? It's maximum number of spells Ifede can use. It takes blank spells to defeat each troll, and Ifede can use a maximum of blank spells. Can Ifede defeat 7 trolls and 15 goblins without running out of spells? Okay. So we've got some quantities here, a number of quantities. This problem in particular tells us what the quantities are, tells us what variables to use. And so that's nice. When we're going to do a second read, we're going to have this in mind, right? It tells us that T represents the number of trolls. So we know what that T is. And G represents the number of goblins, right? That Ifede can defeat without running out of spells. So we know what we've got here is a scenario of Ifede or somebody has come up with an inequality relating the number of trolls and the number of goblins that Ifede can defeat. And now we're going to read it again. Ifede can use a limited number of spells to defeat trolls and goblins. So there's a limit on the spells, and that's why you can only defeat so many. It takes the same number of spells to defeat each troll, and it takes 3 spells to defeat each goblin. So we don't know how many spells it takes. How many spells it takes to defeat each troll. We know it takes 3 spells to defeat each goblin. According to the inequality, how many spells does it take to defeat each troll? Okay. So 85 has to be the total number of spells that Ifede has. Now, how do I know that it's that and not something else? Well, because they tell me this 3 here. And if I look at the 3 and this 3 here, I know that if I was to consider a different or equivalent inequality, and if I was to multiply both sides of this by 2 to get 10t plus 6g less than or equal to 170, then the coefficient of g would not match this 3. The fact that it matches the 3 tells me that if I do 3 times g is the number of goblins that you can defeat. So the number of goblins times the number of spells that the goblin takes to defeat. This quantity right here is going to give me the number of spells used on goblins. Number of spells for goblins. So now if we solve, so the maximum number of spells that Ifede can use, that's 85. How many spells does it take to defeat each troll? That's the 5. So we have 5 here, 85 here. Can Ifede defeat 7 trolls and 15 goblins without running out of spells? So now we can just plug that in to see. 5 times 7 plus 3 times 15. Is that less than or equal to 85? Question mark. 35 plus 45 equals 70. And that is in fact less than or equal to 85. So yes, he can. That's a fun and somewhat confusing problem. At first I thought there wasn't quite enough information, but I changed my mind as I worked through it. Takes 5 spells to defeat each troll, and use a maximum of 85 spells. Can Ifede defeat 7 trolls and 15 goblins? Yes, he can. And we get our dingling. System of inequalities word problems. A whole nother word problem jam. Let's copy this one and dig into this. So, and again, I'm going to read it fast, then I'm going to read it slow, make sure that I carefully read the problem. An electric filter purifies air 35 minute, 0.8 joules per minute, purifies water 25 liters per minute, 1.3. Filter is expected to purify more than 1,000 liters of air and water while using less than 170 joules of energy. Let A denote the minutes spent purifying air and W the minutes it spends purifying water. Write an inequality that represents the condition based on the number of liters of air and water, and inequality based on the number of joules. Okay, let's read it more carefully this time. We weren't told. Oh, no, we were. A, number of minutes spends purifying air. W, number of minutes spends purifying water. So if we're looking to make these problems a little bit harder on ourselves, we could leave this sentence out and try to do the problem without that. But we're being told that, so let's use it. We know that A is the number of minutes to purify air, W is the number of minutes to purify water. So we want an inequality that has the number of liters of air and water in it, and another inequality that also has A and W, but that goes with the joules. So now we got to read again and think, okay, so I want to write an inequality that has something about number of liters. Electric filter purifies air at the rate of 35 liters per minute, purifies water at the rate of 25 liters per minute, expected to purify more than 1,000 liters of air and water while using less than 170 joules of energy. So there, 1,000 liters of air and water is the total number of liters, so that's going to be on the other side. 1,000 liters of air and water. So we've got on this first one, on number 1, we're going to have something with A's and W's in it on one side, and on the other side we're going to have 1,000. Now the thing with the A's and W's, is that going to be less than 1,000 or more than 1,000? Well, it says the filter is expected to purify more than 1,000. So the A's and W's needs to be greater than, and not greater than or equal to. No equals, because it doesn't say more than or equal to. It has to do more than 1,000. So we have some A's and W's greater than 1,000. Okay, well, let's figure out what the A's and W's are. A is the number of minutes it spends purifying air. W is the number of minutes it spends purifying water. 35 liters per minute of for air, and 25 liters per minute for water. So if we take the number of minutes on air, so A, and multiply by 35, that's going to give us the amount of air purified. And now we need to add 25 times W to get the amount of water purified. And we need to check to see, is that greater than 1,000? So we have in here 35A plus 25W greater than 1,000. And down here, an inequality represents the condition based on the number of joules of energy. Okay, so now we're going to relate joules of energy. And here we see the filter purifies air at the rate of 35 liters per minute and uses energy at a rate of 0.8 joules per minute. So we've got 0.8 joules per minute. And A is the number of minutes, so 0.8A. That's going to tell us the joules used on air plus 1.3 times W is the joules used on water. And it's going to have some relationship to 170 joules of air. So what's that relationship? Is it less than or is it greater than? Well, it tells us that it uses less than 170. So we have our two inequalities. And we can try those out on Khan Academy. 35A, whoa, what, I hit plus 25W greater than 1,000 0.8A plus 1.3W less than 170. And we check to see if we got it. And we did. Okay. We're getting there. 4 left. Computer's slowing down. Getting tired. Just going to get all these to load. Analyzing structure with linear inequalities. It's a good one. This is the 11th one. I don't even remember. I didn't realize we had this many. A bag has more green balls than blue balls, and there is at least one blue ball. So this problem really, you can utilize those multiple choice answers, but we're going to try to do it without, because I think it's a really good one to practice. There's a lot of skills here that are easy to miss, even if you've studied this already. So it's easy to get these problems wrong. So let's see if we can make sense of it and come up with strategies that are really effective at solving this kind of a problem. A bag has more green balls than blue balls, and there's at least one blue ball. Let B represent the number of blue balls, and G represent the number of green balls. In this problem, we're being asked to write the equations, and we have no numbers to work with. When we look at the cube strategy, which I keep failing to go all the way through, right? C is read the thing carefully. U is make sure you understand it by trying to restate it. B is break it down into some steps. Figure out, is this a systems problem where I'm going to use something like substitution to solve it? E is actually go through and execute it. And then S is a really important step in the whole process. Remember, that was see if the solution is sensible in the scenario, right? We want to see if it's sensible in the scenario. We want to see if the answer makes sense. And we don't have any numbers to work with here. Well, why don't we toss some numbers in? It's not asking us to come up with numbers, but it wants us to come up with an expression. And numbers can really help make sense of a problem like this. A bag has more green balls than blue balls, and there's at least one blue ball. Okay, well, let's say there's 2 blue balls. Just making up that. Completely made up. Made up. Can't stress it enough. I'm not saying there's 2 blue balls. I'm saying I'm pretending that there's 2 blue balls to help me understand the relationship. A bag has more green balls than blue balls. So let's say there's 3 green balls. Let B represent the number of blue balls and G represent the number of green balls. So we have 2 and 3. Let's compare the expression 2B and B plus G. Which statement is correct? So I'm going to start by using these numbers here, right, to think about. Okay, so 2 times 2 is 4. 2 plus 3 is 5. If I look at 4 and 5, well, 4 is less than 5. Does that mean that 2B is always less than B plus G? No, it doesn't. Not definitely. I just made those numbers up, remember. But does it mean that B plus G is never greater than 2B? Yes, it does, right? We have a counterexample to the kind of this claim. We know that that can't be true. We know that 2B is not always greater than B plus G, right? It's possible it's greater sometimes, but it's not always greater. So it's actually incorrect for me to say this. We don't know that it's not greater than. We just don't know that it's greater than. So let's write that carefully. To be not greater than means that it's less than or equal to. But what we know is that it's not this. We know that is not. We can't say that. We can't say that's correct. Not correct. Doesn't mean the opposite is correct. We have a counterexample of this claim. It doesn't mean that it's always wrong. Right. And now we can start, once we've done this with some numbers, we can start really thinking about the relationship. So B represents the number of blue balls and G represents the number of green balls. A bag has more green balls than blue balls, and there is at least one blue ball. Green, more than blue. And we want to get to something like this. We want to get something like B plus G. So what do I do to this? Well, what if I add B to both sides of the inequality? Am I going to change the relationship of G and B? B plus G greater than B plus B. Right? I just added B to both sides. What does that turn into? B plus G is greater than 2B. And we see that B plus G is always greater than 2B. So we see that it ends up that not only was this not true, but the opposite is true. B plus G is always greater than 2B. Never equal, always greater than. Always true. And it works with our numbers. Just to double check, 3 and 2, right? 3 green balls, 3 and 2. 5 is greater than 4, right? Doesn't mean it's definitely right, but it's at least some sanity check, and it helps us to think about the general case. The specific helps you to think about the general case. So now we go back, and we see B plus G is greater than 2B, right? And we can note, I read this from right to left. I just kind of did it without thinking about it. It's just kind of thinking about the relationship in the other way. We have 2b on the smaller side, b plus g on the bigger side. 5 bigger than 4. This one is not true. That's the one we showed can't be true with our example. And the equal also can't be true because of the general argument we made. And we have it. 3 left. Equations and inequalities word problems. Write an equation that models, an equation in terms of t that models the situation. I just realized that I should have zoomed this in like right at the beginning. I have no idea why I made everyone squint the whole time reading these problems. That was silly. But you all have young vision. If you do have trouble seeing, please let me know, and I'll. If you do have trouble seeing the problems, I'll fix it on the video. I can give you access to this as well, so that you can have this document. Maybe I'll post it with the video. Takes a long time to copy this over for some reason. I guess that's a good reason not to zoom in. Now it's just sitting here spinning as it tries to copy those bits over. Zooming in increase the resolution, I believe, and as a consequence it's really taking its sweet time. We might have to redo this. Okay, come on. Well, I've frozen things. While we're waiting for that, Samantha opened a savings account and deposited $8,192. This problem is a great problem, but for many of you who haven't seen interest calculations before and who don't feel comfortable with exponential functions, this problem is going to be a heavy lift. So I am going to go through and explain the problem, but I don't expect everyone to know how to do it. Doesn't look like this has an interrupt. So I just need to wait. You kidding me? Come on now. I'm going to splice in. What? Oh, somebody showed me today. Astropad closed, Chrome closed, Zoom closed, settings closed, Gmail closed, Google Calendar, Google closed. I really have barely anything open. Come on now. What am I going to do? I guess I do this. Haha. That worked. Now I just closed it. Oh, it's still running. Let's see if this works. Okay. Well, what do? Do we try it again? Haha. I suspected as much. Had nothing to do with resolution. It was just pure weird chance. I don't know. Maybe. Well, whatever. We've got it there. Yeah, it doesn't look like it. Look at that. You zoom in and it's all it's all pixelated. Tells me it's not very high resolution. I think it was just chance playing games with me. A bag has more. No, this is the. That's the problem we already did. I'm going to cut this part of the video. I am just blabbering. Oh my gosh. Make some sense. I hit cancel. Well, that teaches me. It seems like it is the issue. Okay. Lesson learned. You all learned it with me. We will zoom to our standard zoom. Copy that. Paste that. And it did it no problem. So that really is the issue. Okay. I am going to explain this again. It's just too fun for me to try and explain. Samantha opened a savings account. So here's what's going on. We've got a challenging problem. 6 or 7 students have come and told me that this problem, or told on that the class rep for 6th period, that this problem is really hard and that they don't have the skills to do it. So I hear that. Postponing the due date for this Khan Academy exercise. But I can't resist answering the problem. I made a video with some students after 6th period answering this problem, this exact same problem. So I should be prepped and ready. The key strategy, it's kind of comes out of cubes, but it's more of a problem-solving strategy. It's you can't solve the problem, so make an easier one and solve that. And use the process that you use to solve the easier problem to think about the harder problem. So let's make up a problem with much easier numbers. $100. Account earns 100% interest every year. And now we want to capture this idea in an expression. We're told that our years are in T. Before, second strategy, before trying to, and this is really just like the last one that I talked about, before trying to write the expression with a bunch of algebra in it, use numbers, put it in a table, and see if it makes sense. Okay, so we have T years. We have, let's make up a variable for the amount of time, A. The amount of money in the account, A. Amount in account. So T is the amount of time. At 0, how much money is in the account? Well, that's when we had $100. Right? Remember, made up. We're in made up land here. We'll go back to the real problem after we solve the easier one. After a year, what happens? How much money do you have in the account? If you earn 100% interest, well, 100% of 100 is 100, so you'd have 200. And then, one more year later, and this is where a lot of students put 300. Very common answer. But think about that. After you've had your money in the bank for a year, you could take it out. You got $200. The bank isn't going to get you to keep your money in there if they're not going to pay you interest on the whole money. You might as well take it out, right? Or take out 100 of it. So they're going to pay you interest on the full 200. Right? That's what this annual interest means. Right? You're now earning interest on this, so not 300, but rather 400. 100% of 200 is 200. And then after 3 years, same thing happens. 100% of 400 is 400, so you have 800. you look at this and you see the pattern multiplying by 2. And you ask yourself, what kind of operation does repeated multiplication, multiply? Well, let's slow down a little bit. You might already have something in your head, but if you don't, let's slow down a little bit and see what we can do here. See how we can get this 400 from this 200, right? What have we done to the 100 to get the 200? We multiplied by 2. What do we do to that 200 to get the 400? We multiply by 2. What do we do to the 400 to get the 800? We multiply by 2. Let's use the associative property and focus on these 2's together. What's 2 times 2 times 2? Yeah, it's 8. But what's another way to do that? Right, and I'm kind of hinting at it. And really, there's a step here that takes knowing, probably having seen at some point, that what you can do is you can clump those 2's together. Multiplying by 2 3 times is the same as 2 to the 3. Look at that 3, right? Multiplying by 2 3 times. That's exactly how we got this 800. We multiplied by 2, 1, 2, 3 times, right? That's where that 800 came from. That 3, those are the same 3's. What if we went all the way down here to year t? Well, it's going to be 100 times 2. And how many times do we multiply by 2? T times. 100 times 2t. Okay, so now we have an expression that works for this situation here. Let's make it a little harder. I think before we go to this problem, we want to make it a little harder, but not quite this hard. Let's stick with the $100 and not do 100% interest, but do 50% interest. Still in made-up land. And we're still going to make the table. And we're still going to start with 0. $100. 50% interest after 1 year. 50% of 100 is 50. So you have $50 in the account? No, that doesn't make sense. That's getting charged 50% interest. You have 150. Where did that 150 come from? Well, it was the original 100 plus the 50 that you got for interest. Now what about the second year? Well, we know we're going to take the 50% of that 150 and we're going to add it to 150. So we have 150 plus, and what's 50% of 150? Well, a good way to do this, think of 150 as $1.50. How many quarters is that? 4 quarters and $1 plus 2 for 6 quarters. Cut it in half. 3 quarters, 75 cents. Oh yeah, okay. 75 cents, $2.25. Okay. And see where this 225 came from. We're not just trying to calculate these numbers, right? Remember, we're in made-up land here. We're in made-up land here. We're not trying to get the answer. We're trying to figure out how the answer came to be. So we're trying to figure out why this is working. So where did that 225 come from? Well, it was this 150 times 50 plus the 150. Right? In other words, 150 plus 150 times 0.5. One and 50. 100%. Oh my gosh. 100% of the original amount and 50% of the original amount, which is 150% of the original amount, or 1.5. Oh, so you're saying we could just multiply here by 1.5. Where'd that 1.5 come from? Right here. So we're multiplying by 1.5 over and over. As a bonus, Check this out. Remember your distributive property? Those two are the same. Should start popping out at you. Factor this. 150 times 1 plus 0.5. And there's your 1.5. Using factoring to see the same thing. Oh, and that's off the bottom, sorry. Are we ready to go back to the original problem? I think so. Samantha opened a savings account. Now we're reading it carefully. Opened a savings account and deposited $8,192. So that's our starting value. So I'm making a table. 8,192. That's at 0. Account earns 10% interest annually. She makes no further deposits and does not withdraw any money. In T years, she has $25,710 in the account. Okay, well, let's skip this $25,000 for a minute and just come up with the expression. So after 1 year, what am I going to do? What am I going to multiply by? 10% of 8,192 is 819, right? Divided by 10, $819.20. But I need to add it to the original amount, 100% and 10%, 110% or 1.1. So we're multiplying by 1.1. And there's our repeated multiplication. So we have 8,192 times 1.1 to the power of t. And what do we want that to be equal to? That should be the amount of money in the account, equals 25,710. And there's the answer to the problem. A great fun problem, an opportunity for me to throw some exponentials at you, but probably not fair for me to give you. And I appreciate the feedback and take that pretty seriously. Let's see if we even got it right. We did it. And as a bonus, our next problem. $10 per day to use a brick oven, $2 per pizza for the ingredients. One day, Dominic realized that if he switched to an electric oven, the use of the oven would cost him $20 per day, but the ingredients would be cheaper, only 80 cents per pizza. This way, his total expenses for each day, including shared oven costs and ingredient costs, would be reduced by $1. Okay, if you want to have fun with this Khan Academy exercise, please help yourself, dig in, have fun. This problem, involves skills that I think you're already going to be relatively strong at. So maybe a little less intimidating. Still a challenging problem. And an excellent SAT practice problem. Let's go to this. This problem, I don't even know if we need to copy it. It's really all about what the graph looks like. Graph labels and scales, making sure you know how to make a good graph. So you're looking at this graph. Honestly, the first time I did this, I got this wrong because I was not reading carefully enough what it's asking. You got to read these multiple choice questions carefully. Tells us some information here. Matthias models, blah, blah, blah. Good reason to read this fast. When you get down here, what mistakes did Matthias make when drawing the graph, right? You realize that what you need to do is really just look at the graph. Inappropriate scale for the x-axis. Well, that's going to take us some seconds to figure out if that's right or wrong, right? We might need to look up here. Inappropriate scale, I need to know what this x-axis is measuring. Inappropriate scale for the y-axis, same thing. I need to know what it doesn't say over here what this is measuring. And look what the next thing is. Wrong missing label for x-axis. Here's the one for the x-axis, years since 1950. Wrong missing label for y-axis. There's no label over here. I can't see it. So I definitely need to include that. C has a label, so I don't include that. I know D is one of the answers, but I have to choose all the answers that apply. Maybe it's just D. So I got to verify A and B. But I know it's not C. So I cross off C. Choose D, and now I look at A and B.
Matthias models the relationship between Australia's gross domestic product per capita P and time T in years. In years after 1950, let's focus on the x-axis first since that's part A. Years after 1950. So this is years after 1950. That's 0 years after 1950. This over here is 50 years after 1950. 50 years after 19, that would be 2000. Okay. He wanted to create a graph to show the relationship until the year 2000. Oh, that's what it goes up to. It goes up to 2000. Okay. And it starts at 0, starts at 1950. The relationship until the year, so I should start at the beginning and go until 2000. Well, it does that. So it is not an inappropriate scale for the x-axis. I can cross that off. Inappropriate scale for the y-axis. Now we look at the y-axis. Y starts at 0. This is by 5,000s. 0, 5,000, 5,000 more, 10,000, 5,000. All the way up to 45,000. I'm going to write a K so I don't have to draw a bunch of zeros. 45K, 45,000. Let's see. Oh yeah, you can see right here on the graph, it just barely includes the top of the graph. Like if I went up to 50,000, then it would go up higher. You know, might be good. If it only went up to 25,000, then I wouldn't see this whole part of the graph. So it seems like that's a pretty appropriate scale. So I would say it's not an inappropriate scale. And Matthias didn't make, we already decided he definitely made D, so we can click yes, and we get our little sound, and we're on to the last one. Modeling with multiple variables. X delivery persons carry a total of B bags of groceries up the stairs. I'm so optimistic. It's not going to fit here, and then I'm going to have to deal with it not fitting. But I'm going to be stubborn and say, oh, no, it's going to fit. X delivery persons carry a total of B bags of groceries up the stairs. That's hard to read. Let's make that a little bigger. They can each carry Y bags at a time, and they each make 2 trips up the stairs. Write an equation that relates X, B, and Y. X delivery persons carry B bags of groceries up the stairs. They can each carry Y bags at a time, and they make 2 trips up the stairs. So how many trips do they make? How many trips do the delivery people in total make? 2x. In 2x trips, total trips, in 2x trips, if they carry Y bags, each person carries Y bags at a time, 2x, the total trips, times Y should tell me the total bags. And what's total bags? What just happened? Weird. Sometimes this thing, like, total bags, so that equals B. Okay, let's just put that in. Doesn't seem a lot to do on that. Oh, I was telling you that we should always consider some numbers on this. I'm running out of steam. I'm just going to put it in. 2xy equals B. We got it. Let's do one more. Callan is making, so that everyone knows, I got some feedback that this one was also pretty challenging, so I wanted to make sure we got one that students were likely to have struggled on. I'm going to go to a new page just in case. I haven't read this problem yet. Come on. Callan is making pizza.
using flour, tomatoes, and mozzarella cheese. Table gives the cost per kilogram of each ingredient and the amount in kilograms that Kellen uses. Okay, so flour, tomatoes, mozzarella. Total amount Kellen spends is C. Write an equation that relates X, Y, and Z. Oh, we're told that X is the kilograms of flour. I didn't even know where the variables were. Y is the kilograms of tomatoes. And Z is the dollars per kilogram of mozzarella. Why do they got to do that? Because they want to make it fun. They want to mess you up. Come on. Get in the game, right? So X kilograms times $0.8. X kilograms. This is called unit analysis that I'm doing right now. Times $0.8 per kilogram. Dollars per kilogram. Now, if I multiply those, what am I going to end up with? Well, those kilograms cross off, and I get dollars. So this expression, X times 0.8, is going to give me the dollars of flour. I want to know the total amount Kellen spends. So here, this is 0.8x. Down here, this, same thing, 330 per kilogram, Y kilograms, 330 Y. This one, Z dollars per kilogram, 0.5 kilograms. Well, they didn't get it very interesting. It's just 0.5 Z. And you add all these up, and you get the total amount spent, right? Dollars per kilogram. The kilograms still cancel. The dollars in the top. C equals 0.8x plus 3.3y plus 0.5z.
And we are done. Have an excellent weekend, everyone. Enjoy yourselves. And I'll see you all next week.